Hi everybody. What we're going to do is we are going to connect the geometry ideas that we've talked about so far this year. So we started talking about geometry and we talked about congruence and similar figures, and then we most recently talked about angle relationships. So what we're going to do today is we're going to talk about congruence and similarity and angle relationships, all when it comes to triangles. So today we're going to talk about how the angles in a triangle are related, how the sum of the three angles in any triangle are going to add to 180 degrees. And we're going to use these angle relationships to help us solve problems about triangles and other polygons. Our big idea to start out with is that the measure of an exterior angle of a triangle plus the measure of the interior angle that's adjacent is equal to 180 degrees. So let's see that drawn on the board. So here we have a triangle and one of the sides is just a little bit longer, and that's going to help it create our exterior angle, which is on the outside of the triangle. So we have our exterior angle, and on the inside of the triangle, adjacent to that, we have our interior angle, our inside angle. What we see here is we have an exterior angle and an interior angle, and they are part of a triangle, but what we can see here is that this straight line means that these two angles are supplementary. And we're going to find that this works the same way with any exterior and interior angle pair that are adjacent. They're touching when you extend any of these lines of the triangle. So there's something else that really cool that we can do here. So we can relate the idea of exterior and interior angles to the idea that all of the angles of a triangle equal 180 degrees. We know the sum of the three angles of any triangle are going to equal 180 degrees. It doesn't matter if it's an acute triangle, an obtuse triangle, a right triangle, isosceles, equilateral. All triangles have their three interior angles, those inside angles, that add up to 180 degrees. So what we then can find out is this. If we were to label this triangle here, that's really similar to that one, with the interior angles being X, Y, and Z, and that exterior angle right there being W, we know this. We would know that X plus W would be equal to 180 degrees. And we know that because these angles create a straight line, so they're supplementary. That's 180 degrees. We also know this. X plus Y plus Z is going to equal 180 degrees. And we know that because they are the three angles that make up a triangle. So what we can really figure out here is something cool. When we combine these and we simplify them down, we find that the measure of this exterior angle W is going to equal the sum of the measures of the two non-adjacent interior angles, Y and Z. And this is because X plus W, which is 180 degrees, is the same as X plus Y plus Z. When we simplify this down, we can find parts of this equation that are equal. We know X is equal to X, 180 is equal to 180, and what we're left with is this. We're left with the idea that W must be the same as Y plus Z. We can use this idea to solve some pretty cool problems. Now we're going to use the idea of angle relationships in triangles to determine angle measurements in similar triangles, and determine if triangles are similar to one another. So here we have two triangles, and they're clearly different size, so they're not the same. We have triangle ABC, and triangle DEF. And we want to know the measure of this third angle in each of them. So what's really interesting is these triangles each have two given angle measures, and they're the same. So angle A is 20 degrees, and so is angle D. I have them color-coded because I know on triangle DEF, it's a little bit hard to read because the print's so small, but angle A and angle D are congruent. They're 20 degrees. I'm also starting out the problem knowing that angle B and angle E are congruent. They're 115 degrees. So knowing these two angle measures of these two triangles, we can find the measure of that third, because we know this one and big important rule from today: the three angles of a triangle all add up to 180 degrees. If we were to solve this algebraically, we could set 20, 15, and an unknown equal to 180 and solve for angle C. So it would look like this: 20 plus a 115 plus angle C equals 180 degrees. So we did some math, and we find out that C must be 45 degrees. And we know that angle D and angle E are the same as A and B, so we don't even need to do math here. We know that if we have two triangles and two of their angle measures match, the third one that we don't know has to be the same in both triangles, because in both cases, those three angles need to add up to 180 degrees. So without doing any math, I know that angle F must be the same as angle C, so angle F is 45 degrees. So here we're tying together the ideas of congruence and the idea that all three angles of the triangle have to add up together to be 180 degrees. We're going to do one more example to show that if two angles in one triangle are congruent to two angles in another triangle, then the third angle in each triangle must also be congruent. So let's draw this other example out. So we can see that we have two new triangles, PQR and STU. So we've got two given angles for each. P is 30 and angle Q is 60 degrees. Angle S is 30 degrees and angle T is 60 degrees. So it can look a little confusing right now, because in our last example we had triangles that you could look at and see they were very similar, just different sizes, but here, ooh, they're kind of rearranged. This one has a smaller angle on the left and gets bigger, and this one has a small angle on the right. So how do we know for sure that angle U and angle R are going to be the same size? What we do to figure this out is we use that simple rule that the three angles of a triangle are going to add together to be 180 degrees. What we can do here is we can double check that 30 plus 60 plus angle R is going to equal 180 degrees. So we have 30 plus 60 plus R equals 180 degrees. We do a little bit of algebra and simplify this down. 30 plus 60 or 90 plus R equals 180. And 90 plus something equals 180. And I know 90 plus 90 is 180. And here we have our answer. That angle R is 90 degrees. Now, the rule that we talked about, where if two angles are congruent in two different triangles, then the third angle has to be congruent. But we're going to double check here to make sure that we got this right. So we know that the rule of triangles is the three angles together have to add to be 180 degrees. So let's check this out. S, 30 degrees, plus T, 60 degrees, plus U, an unknown, is going to equal 180 degrees. And we're going to set this up algebraically again. So we've got 60 plus 30 plus u is going to equal 180 degrees. I do a little bit of algebra combining these. 60 plus 30 is 90. Then I bring down the rest of what I have, u and 180. Now I have 90 plus whatever u is equals 180. So 90 plus something equals 180. And I know again 90 plus 90. Again, we've proved that u is equal to 90 degrees. So we showed not only do the three angles add up to 180 degrees in both triangles, that's always going to be the case, but we showed that because we knew we had two congruent angles in these two shapes, that third angle in both triangles, that unknown angle, they had to be the same as well. So we've learned a few things about triangles today. The interior angles, the inside angles of a triangle, are going to add together to be 180 degrees. The measure of an exterior angle equals the sum of the two non-adjacent interior angles, the two inside angles of that triangle that don't touch that exterior angle. If two angles in two triangles are congruent, then the third angles are congruent as well. They are the same. Today we learned these three things. I hope you learned a little bit. Have a good day, be kind, and work hard.